Alright, this subtopic will be power. So when we say powerful means that we can actually do work faster. Okay, a car is powerful. That means it can produce more energy per unit time. So the definition of it is the rate of doing work. You can also define it as the amount of work done per unit time, or you can also say the energy transfer per unit time, because energy and work done basically they are the same thing. Alright, so we have the equation P equals to W over T as in work done per unit time. Sometimes you can also use the change in the energy per unit time. Sometimes it will be change in the kinetic energy per unit time. Sometimes it can be the change in the gravitational potential energy per unit time, or any other forms of energy per unit time. Alright, unit is watt, W-A-T-T, watt. Symbol is capital W. We also have a variation of this equation of the power. So let's look at how to convert into that. So power is equals to work done per unit time. That we know work done can be is defined as force times displacement. Then we divide by time. So this is force times displacement. Then divide by time. And displacement itself divide by time is actually the velocity, rate of change of displacement, if you remember. Therefore, for a case where we have, let's say, the engine in the car, that it is trying to move a car, that it exert a force on it, that cause the car to move at a velocity, a certain value of the velocity, then we can calculate its power at that moment will be equal to the force that it exerts on the car times the velocity of the car that's moving at. Okay, so take some example here. Engine of a jet plane. Okay, it developed 3.5 megawatt of power at a constant speed of 120 meter per second. Calculate the air resistance or drag force on the plane. Okay, so there are a lot of forces acting on this plane as it accelerate. No, sorry, it's not accelerating. As it move in the air, we have looked at this in the exercise during the identifying the forces acting on the system. So more importantly is the horizontal force in this case, that the engine is trying to exert a forward force. Okay, and then air resistance is trying to resist its motion. Okay, so this is F for air resistance. This is the forward force by the engine, Fe. Okay, so we know that it developed 3.5 megawatt. So we can write force times velocity, because we know that it's moving at a velocity of 120 meter per second. We are going to use this equation because instead of the equation of work done per unit time, because the factor of time is not involved here, so this one will be more convenient. So if we sub in the 3.5 megawatt and the power 6, we can actually calculate the force that the engine is trying to give to the jet plane. So once you get that value, we can now deduce the value of the air resistance. Okay, so remember, when it moves at constant speed, acceleration is 0, and therefore forward force equals to the backward force, producing a 0 resultant force. Therefore we can say that the forward force by the engine actually is the same as the air resistance, because balanced by the air resistance, and therefore the air resistance will have the same value as your engine force here. Okay, next case we look at The power necessary to move a box of dynamite of the mass of 1.5 kg up a smooth plane. That's a smooth plane, no resistive force between the two surfaces, okay, at an angle of 25. So here is 25 degree at a uniform speed of 3. So again, there's a statement here, uniform speed. That means the downward force, which is part of the gravity, will be same as the forward force that the man is trying to exert on it. So F naught, let's say. This is the gravitational force, partial gravitational force. Okay, and if we are looking for the power, again we use the equation of Fv. Okay, because the factor of time is not involved here, so this one will be convenient, like the case just now, that we know the speed is 3. The speed is 3. However, we need to figure out what's the force here. Okay, basically it's the F naught, but F naught, as in the force produced by the man, is not mentioned here, so we're going to deduce that. So the same thing here, forward force equals to upward force equals to downward force. Therefore, we can write Fg, that's the downward force by part of the gravity, equals to the force of the man. The man has to exert at least the same amount as the part of the gravitational force. Okay, so therefore F naught is equals to 1.5 9.81, the weight, and its component is sine 25. So again, this is back to the resolving of a weight in inclined plane. Okay, so very important, yeah, you must know. 9.81. Okay, so once you sub this inside here and multiply by 3, then you should be able to get the answer. Okay, right, next one, that will be your assignment question. Okay, so please read the question very carefully. Yeah, all right, we'll stop here.